Here we are looking at our 8.5 set of notes. We're discussing surface area and volume of cylinders and cones. So as we can see, we have the surface area for a cylinder that we're first trying to figure out. And where the proof for this guy comes from is, imagine a cylinder, and you have a base, which is a circle here. And for the surface area, the area of a circle is pi r squared. And then imagine we have two of these. And so that's where, if we were to lay this guy out, our base is that pi r squared because it's a circle. But then again, if we were to kind of unfold it outward, this lateral area being created from the actual cylinder part creates a rectangle. And so where that rectangle comes from is our circumference from the circle times the height. And so that's why we have a surface area equation for a cylinder being 2 pi r squared because there's two of those circles. And then the lateral area, this is the 2 pi r times h. That's that rectangle that you just saw a moment ago. Okay, so this is our equation that we're going to kind of work with. Now, usually when we're working with this, I do encourage students to kind of like break it up because then it usually just kind of spatially, it makes more sense. And so you'll kind of see what I mean by that in here in a second as we kind of work with some of the examples and the numbers. All right, so for our first one, we have to find the surface area for this cylinder. And right away, we see that our radius is the 2 millimeters and our height is acting as the 5 millimeters. So what we're going to do first is find the area for a circle, just one of the circles. And we know the area for a circle is pi r squared. Well, we can go ahead and dump in our radius. So the area is equal to pi times 2 squared. And then our area comes out to be pi times 4, or 4 pi. Now, because we have two of these circles, we're going to go ahead and multiply this by 2. So that's what I mean by breaking it up. So we're finding like one item and then recognizing, oh, wait, we have two of those though. One from here and this side, and one from the other side. And so when we find that area, we end up with a total of 8 pi. Now let's go ahead and figure out what is our lateral area. Now to find the lateral area, we know that it follows area equals 2 pi r times h. So this is for our rectangle. And again, that circumference of the circle is really what helps us create that like length around that we're talking about. And so for our area, it comes out to be 2 pi times our radius here is 2, and our height here is 5. Now we simply clean this up. Area equals 2 times 2 times 5, which gives us 20 pi. And now what we're going to do is we're going to combine the two areas together. Typically, we want to approach problems like this because here we'll end up with a surface area of 28 pi, and this is an exact value. So you kind of want to hold off on the whole pi part for the very, very, very end. And so again, here is our surface area. And again, this is millimeters because we're finding surface area. This would be millimeters squared. So that is the exact value. Now, if we go ahead and find the approximate, like where we don't have the pi, personally, I believe in using the pi button. So if you were to plug this into a calculator, you should get 87.96 millimeters squared. Okay. The reason why I prefer the pi button is it's just more exact, so you get a better approximation. Now, if you were to use 3.14, it's okay, but generally speaking, use the pi button. All right, looking over at number 2, again, here's our radius and here's our height. And so we're just going to break this up. So we have our circle, and our circle is area equals pi r squared for a circle. So we're breaking this up where we just find the circle. We know our radius is 6 squared. And then we have our 6 squared, which is 36. So we end up with 36 pi. Now, again, we know that we have 2 circles. So essentially, we're just going to double that. That's where that 2 comes from. And we're just going to double that. So area comes out to be 72 pi. Again, keep things in terms of pi. Don't multiply it by pi just yet. We're going to save that for the very end. Now comes our lateral area. Sometimes you'll see it represented as just L period A period. And so this again is area equals 2 pi r times height. So when we go ahead and plug those values in, we end up with area equals 2 pi times radius is 6, height is 7. Cleaning this up, we get 84 pi. And now what we're going to do is we're going to take our 84 pi and our 72 pi and add those together. So 84 pi plus 72 pi gives us in grand total 156 pi's. So our surface area is equal to 156 pi, and this would be feet squared. Or in terms of our decimal value, it would also come out to be 490.09 feet squared. Shout out to my guys who were able to help me out with the calculator computations. Go ahead, feel free to pause the video though if you have any questions at all on these two. All right, next up, what I would like for you guys to do is to give this one a fair shot, try it on your own. Now, just be careful because on this guy, we're going to start off barely together, but notice on this one, they give us actually the diameter, right? The diameter, when it shows that red line through the whole thing, that's our diameter. And so as a result, our radius, which is really what we need to use, our radius is actually only half of that. So in reality, our radius is 3 that we're going to use. Okay, so it's about 50-50 whether they give you the diameter like that or kind of like the other ones that you've seen with me where they give us the radius. So they, they could give you either one, but it's pretty 50-50. So go ahead, give that one a shot, and then we'll come back together and then we'll see how we did. All right, now that you've had the opportunity to try it, we have our circle. And again, for the area, that is pi r squared. So our area equals, again, this is our radius, this is our height. Our radius is 3 squared, so our area comes out to be 9 pi. But again, we have 2 circles. And so we're going to multiply that by 2. So as a result, we get 18 pi. Now you might be thinking, but hey, Mr. V, I kind of know that there's already 2 circles. Can I just put the 2 right here to begin with? And the answer is yes, you could. You could absolutely do that. Why are we breaking these up though, kind of the way that we are with the times 2 circles? It's because as you especially get into higher level maths like your honors geometry, you're going to have, or even regular geometry, you're going to have more shapes that it's just kind of better to dissect it and break it apart as a net. But it certainly can be done with formulas as well. But usually for most students from their experience, how I've at least seen is breaking them up item by item. It just kind of creates that good habit where you can actually visualize in your mind, okay, this is where this is coming from. And this part is where this is coming from. So, you can absolutely put the 2 here, but I'm trying to create more of that habit of you're breaking the shape up and then you're understanding the why different things are the way that they are with the actual equations. All right, next up, we have our lateral area. So for our lateral area, we have area equals 2 pi RH. And so we go ahead and place those values in. So 2 pi times the radius is 3 times the height is 12. And so for our area, we end up with, looks like 36 times 2, which is 72 pi. And then we go ahead and combine these two items together. So our surface area is equal to, looks like 90 pi on this one. And this would be centimeters squared. And so when we find that value, we see that it is 282.74 centimeters squared. Okay, go ahead, feel free to pause the video if you have any questions on that one. All right, now we're shifting gears towards this application question. Here we have a tanker, and the truck's tank is a stainless steel cylinder, and we have to find the surface area of the tank. Pretty much, guys, it's pretty similar to what we've been seeing. We have our height here is 50, and our radius is 4. If you want, go ahead and feel free to pause the video and give that one a shot. All right, now that we've had the opportunity to try it, let's see if we can get the same value. So our area for our circle is pi r squared. And the reason why is we have two circles, one on both sides. And so for our area, we have pi times our radius here is 4 squared. And so then our area comes out to be 16 pi. Now for our lateral area. Oh, I'm sorry. We have times 2 though, 2 circles. So in total, it'll come out to be 32 pi. Now for our lateral area. Well, our area equals 2 pi times radius times the height. So plugging those values in, we end up with 2 pi times 4 times the height is 50. In which case, then we get, that's 200, so 400 pi. And then lastly, we just add these items together. So you're kind of just seeing, oh, it's really just a application, but it's important to kind of know so that, for those who are creating cylindrical shapes, they can have enough materials to actually do that. So 432 pi. And then as a result, in terms of a decimal, that would be 1357.17. Here we're talking about feet. Yeah, feet squared. Feet squared. All right, moving on. Now we're going to be shifting gears towards the volume of a cylinder. Okay, and generally, by and large, my guys actually prefer volumes over the surface area. Now, in a lot of geometry, the volume for a lot of shapes is really just your base, your area of your base times your height. And this base generally is going to be different from the shape that you're actually seeing. Okay, so for us right now, because we're talking about a cylinder or in the future a cone or whatever, it's going to be pi r squared because our base is a circle. That's not always going to be the case. Again, it depends on your shape. So our area for this base is pi r squared. And then again, to find the volume, it's times then that height. The volume of a cylinder is base times height or pi r squared times height. So let's see example 1, and we have to round to the nearest tenth for this guy. So here our radius is 3 and our height is 6. And so what we're going to go ahead and do is write the volume equation. Volume equals pi r squared times height. Again, this part is our base. So going ahead and plugging those values in, we have our radius, which is 3 squared, times our height is 6. And really then we just kind of plug and chug, see what we get. So we have pi times 9 times 6, which comes out to be 54 pi. And as a result, that volume then is the same as 169.6 meters cubed, because we're finding volume now. So we're doing 169.6 meters cubed. And so really these two answers are correct. Okay. Personally, I'm more of a fan of the 54 pi because it's exact. But in terms of real application, that's where the decimal's handy. Go ahead and feel free to pause the video if you have any questions at all. All right, next, what I would love for you guys to do is to please try this example 1, and then we'll come back together and then we'll see how we did. This is for the you try it, so this is really for you to give it a shot. All right, now that you've had the opportunity to give it a shot, we have the volume equals pi r squared times the height. And our height is the 15 and our radius is the 4. We go ahead and we plug those values in. So the volume equals pi times our radius is 4 squared times the height is 15. Cleaning this up a little bit, we get 16 times the 15, which then comes out to be 240 pi when we multiply those together. And so as a result, this would be converted to a decimal. Now, it comes out to be like 753.98. But this 100th place is going to round our 10th place up. And since it's a 9, it actually creates that brand new integer 54 as a result. So it's like it's rounding everything up from the 100th, then to the 10th, and then to actually the integer itself. So that's why our volume comes out to be 754. And this is, again, feet cubed, feet cubed. Okay. Go ahead, feel free to pause the video if you have any questions at all there. All right, now I know we're kind of bouncing around. Trust me, it's actually in a really good order that helps people. So we're looking at example 2. And here we're actually given the volume, right? And we have to actually find then this missing height going on. Well, we do know the volume equation for a cylinder. It is V equals pi r squared times the height. And so what we can go ahead and do is plug in our notes and say, hey, we kind of know our volume is really 314, and we know, well, we know the diameter is 10, right? So our radius, let's choose a different color, our radius is actually 5. But we can go ahead and place these items in there then. So we know our volume again is 314. Our radius is 5 squared. And we have no idea what our current height is, though. That's what we're actually trying to find. So now we end up with 314 equals pi. 5 squared is just 25 times the height. And then what we can do to both sides is our goal is to try and solve for h. We want h all alone. Well, this 25 pi, even pi is actually kind of like a constant. It acts like a constant. So we can divide both sides by the 25 pi. And so on the right side, they cancel, leaving you just your h equals. And then when we plug this in the calculator, it's super important. In fact, I'm going to pause. Go ahead and try plugging that in the calculator for a moment. Now, you may have gotten this. H equals 39.5, right? Now, that's actually incorrect. So, and believe me when I say, like, when we do this in class, pretty much half the guys get that answer. So if you did, trust me, you're not alone, okay? That is incorrect, though, just so you know. You have to be careful on how to program. And pretty much all of mathematics, I'm talking like all of it, what you want to do is your calculator needs to read this as one set. So we're actually going to start off with a parentheses. So you're going to plug in parentheses, open parentheses. You type 314. You close that parenthesis. And then you click your division symbol. And then what we need to do is create this denominator as its own set. So we're going to, again, try and create that set on the bottom. So we're going to open up a parenthesis, type in 25 pi. What the calculator is now doing is it's recognizing, oh, you actually have that as the part of the bottom set, that pi key. And so when you enter that, you should get a height of 4, which is the correct value. Okay. The other way, which your calculator was trying to do, if you didn't have the whole parenthesis stuff, it was trying to do 314 divided by 25, and then that pi was actually kind of getting multiplied by it. So that's how your calculator is registering it. That's how it was thinking it was being, put in, which is obviously wrong. We're dividing the pi as well. And so that's why pretty much, guys, in all of math, see that numerator 314, that's in a parenthesis, divided by, again, opening up a set with a parenthesis, 25 pi. All of math, use parentheses. It will save you, trust me, it will save you so many points, okay? So now that we know the correct value, our height is 4 inches. Go ahead, feel free to pause the video if you have any questions. All right, now what I'd love for you guys to do is to go ahead and please try example 2. Very, very similar question. And again, be mindful of those parentheses. All right, and so just coming really quickly back together. If we plug in our values, keep in mind our radius is 4 here. And so when we plug that in, we find out that H is 3.5 centimeters. Okay, but again, in the calculator, just make sure you have that parenthesis and parenthesis on the bottom. Go ahead, feel free to pause the video if you have any questions. All right, then moving on. For example 3, we're asked how much salsa is missing from the jar. The empty space in the jar is a cylinder with a height of really 10 minus 4, giving us 6 centimeters, and the radius is 5. So in this event, we're actually trying to figure out what is the amount of volume from the salsa that's missing. So we care about this part. And as a result, we know that that is 6 because 10 minus 4 is that 6. So we're trying to figure out what is that cylinder right here, just that top missing part. Okay, so let's go ahead and create our volume equation. So it's pi r squared times height. And we know our height is the 6. And our radius is 5 from the jar. We go ahead and we plug in our nodes. So V equals pi times radius is 5 squared times our height is 6. And so we end up with 5 squared is 25 times 6. And now when we multiply these values together, we get 150 pi. And as a result, our volume comes out to be 471.2. And this would be centimeters cubed. And that is how much is missing from that jar. Looking at example 4, we have how many gallons of water does the water cooler bottle contain? Well, we know that the full diameter is 1 foot, so our radius has to be half of that. So we're talking about 1/2 as our radius. And our height is given, so what we can go ahead and do is plug those items in. Again, V equals pi r squared times the height. Go ahead and try and pause the video and see if you can come up with this. All right, so our two different volumes come out to be 0.425 pi. And as a decimal, it looks like this really, really long thing, right? And so these would be our two different volumes. One, again, being exact. One is that decimal value. That's an approximation, but a very good approximation. Now, our goal is actually to figure out about how many gallons of water does this thing contain. So it does give us this info that one cubic feet of water is about 7.5 gallons. Now, looking at ours, this is essentially saying 1.33517, that's how much cubic feet there are in this jug. So what we can do with that now is 1 foot is 7.5 gallons, and we have 1.33517, cubic feet of this stuff in here. We can now go ahead and take that decimal and multiply it by 7.5. To kind of figure out how much is there in total of gallons here. And so when we do that and plug that into a calculator, we end up with 10.01. We'll just say, we'll go to the 100th place. And that would be gallons. So really about 10 gallons. So even if you put 10 gallons, I would take that. Okay. Go ahead, feel free to pause the video if you have any questions. Again, this is in terms of the cubic feet. So this is our feet cubed part. But the question is really wanting how many gallons are there. And that's why we had to multiply by the 7.5. All right, now go ahead and please try out this one. The cylindrical water tower has a diameter of 15 meters and a height of 5. How much water in gallons can that tower hold? If you know 1 cubic meter is 264 gallons. All right, and so here is that work for this water question. So again, this is our volume, and this is in meters cubed. And so as a result, we want, though, the number of gallons that there are. And there is 264 gallons for every cubic meter. So we're just going to take our value and multiply it by 264. And so when we do that, we end up with 233,263.25 gallons. So 233,263 gallons, pretty much, just from I think it's one of those water towers, right? Yeah, water tower. That's a lot of water, but goes to a lot of good people. So go ahead, feel free to pause the video if you have any questions at all.